This video is going to cover Unit 22, Section 2, Angles of a Triangle. Now, we've already mentioned this, but they re-mention it, that the angles of a triangle all add up to be 180. So the sum of all angles in a triangle are 180. Okay, so let's take a look at example number 2 at the bottom of page 564. And we have a figure that looks something like this. This angle is not that. So, what we're looking for here is angle number 4, which is right there. Now, how do we find angle number 4? Well, we already know that this angle is 64 degrees. We know this one's 43. We know that one's 90. So we can find this angle right here by finding out the angles of this triangle. And since they all add up to be 180, so I put in 180 and I take off the 90. Then I take off the 43 and I get 47. So that angle is 47. Now this angle right here is, this whole angle right here is 180 because it's just a straight line. So 180 minus the 58 and then minus the 47 will get us that angle. So 180 minus 58 minus 47. So that angle is 75 degrees. Okay? So now this angle right here is 180 minus 75 minus 64. So 180 minus 75 minus 64. And that gives us 41. So angle 4 is equal to 41 degrees. So we used all of these other angles to find that one. Now we could also find this angle right here if we needed to, because that would be 180 minus 58 minus 90. And they don't really give us anything over here, so we're pretty much set. We don't know that this is a right triangle right here. We don't know that because they don't give it to us as that. We do know this one is. We can probably guess that this would be symmetrical. So that would probably be a 90, but we don't know that for a fact because it doesn't have that 90-degree angle in it. I kind of wanted to point that out in that one. Even though you can probably guess that it probably would be, but we don't know for a fact. All right? All right, so let's take a look at, on page 566, number 14. I've already got it drawn right there, ready to go. All right, so it says find angle 2, and this one right here is angle 2. This whole angle right here is angle 1, and this angle right here is angle 3. So find angle 2 when angle 1 is equal to 25.782 and angle 3 is equal to 49.489. Okay, so we've got angle 2, 25.728, and 3 is equal to 49.489. Okay, nope, that's angle 1, not angle 2. What we're looking for is angle 2. Okay, so what we know is this angle is 36 And so we have this one plus this one plus this one is 90. So inside, we know that angle 3, angle 2, and angle A all add up to be 180 as well. So this one, and this one add up to be 180. So they give us angle 1. So this angle right here. So what I'm going to do is I'm going to take angle 1 and angle B, and I'm going to subtract them from 180 to find out what angle A is. So 180 minus 36 minus 25.728, and I get this angle right here, angle A, is equal to 118.272. Now, there's two triangles in here, or actually three. There's a big triangle, and then there's a smaller triangle here, and a smaller triangle right here. Now, this angle is for the big triangle and this small one. It doesn't matter which one of those triangles we're looking at. Angle A is 118.272. All right, irregardless. So now what we're doing is we're looking to find this angle right here, the smaller angle. That's angle 2. So we know that angle 3 is this. We know that angle A is that. So I just take 180 and I subtract this, and then I subtract that. So 180 minus 118.272 minus 49.489, and I get 12.239. So that's what angle 2 is in that situation. Now, part B says find angle 3. So we did this stuff. So now find angle 3 when angle 1 is equal to 28 degrees 30 minutes. I'll convert that in a second. And angle 2 is equal to 16 degrees 22 minutes. First thing I want to do is I want to convert these to decimals, just because that's my thing. 28 degrees minutes seconds, 30, then hit the degrees minutes seconds, and then change it. Oh, dummy. I should have seen that. 30 minutes is exactly half. So it should be 28.5 degrees. This one, 16 degrees minutes seconds, 22 degrees minutes seconds, and then convert that. That is 16.37. Okay, so what we're looking for here is angle 3. So right here, I know what this one is, because that's given, and I know what angle 2 is. So if angle 2, 16, I'm not sure that I need to know what angle 1 is, because if I know 2, and I know this one, Wait, it doesn't matter. Yep, okay. So I've got, and now I have a different, I'm going to have a different number for this one right here. So angle 1 is that, and then angle B is that. So B is always the same. So I need to find a new A. That's right. So 180 minus 36 minus 28.5 equals, now our new angle A is 115.5 degrees. So if that's 115.5, I know angle 2. So now what I do is I just take 180 and subtract 115.5, and then subtract angle 2, which is 16.37. I get angle 3 is equal to 48.13. So those are the two angles that we were looking for. Both times we had to find a different angle A. Ta-da! Now let's look at number 15. All right, it says find angle A, which is this angle. I should have drew dash lines right there because this is not part of the figure, but we could take this line right here and extend it, and this line right here and extend it to get this angle right there, even though it's rounded right here. Now, it also says that this line AB is parallel to DE. So that means that line AC is also parallel to DE. All right? Now, we know this is a 90. And angle E, we know that angle E, the at first anyway, is going to be 64.21. Let's find out what that is. 64.21 degrees, minutes, seconds. 64.35. So angle E is can't do that. What? Angle E is 64.35. 64.35. Right there. All right. So because these lines are parallel, let me draw this down here. I'm focusing right here. Okay. Parallel line here. Well, it's not exact. Parallel line here. So right there. So this is E and this is C. And of course D is down here. Now, if this angle right here, these two lines are parallel. So what I'm going to do is I'm going to extend that line. Remember, lines go on forever. And I'm going to go ahead and extend this too. So what we have here are parallel lines intersected by this transversal right here. So these two lines are parallel. So if this angle right here is angle E and it's 64.35, then that means that that angle right there, because these are corresponding angles, remember we just talked about this. So this angle right here, meaning angle C, is also 64.35. So this is that. So 64.35 plus 90. And then subtract that from 180, or just take 180 and subtract 90 and then subtract 64.35. So 180 minus 90 minus 64.35. That gives me 25.65. So angle A is equal to 25.65. All right. Then Part B gives us some different instructions. Find angle E. So this might not be, this probably won't be the same anymore. So find angle E when angle A is, let me convert that real quick, 20, 59, 47, 20 point, we'll just call it 21. We'll just call it 21 because it's 20.996. So that will round up to 21. Okay, so that was for the first part. Now part B, angle A is equal to 21. Now we need to find angle E, right? Angle E. So we know that angle E and angle C are the same. We talked about that down here. So for the 180, what we do is we take 180, we subtract 90. Minus 90, and then minus 21. And we get 69. So that means that angle C is 69, and angle E is going to be the same thing. All right? So on these figures, you have to understand what we've talked about before. Now, at first, this area right here might not look like what we've talked about before, but we have two lines that are parallel right here. This line and this line are parallel. They mention that in the problem. And this is also a transversal right here. Okay? They don't mention that, but it is. But this is the one they're talking about. So we have corresponding angles right here. Now, once we extend the lines, you can see that we would also have alternate interior angles, alternate exterior angles, and all of those other things that relate to parallel lines cut by a transversal. Okay? So always try to envision, you can always extend a line. You can always extend one to help you to see these kinds of things right here. But once we understand about, corresponding angles and alternate interior and all those other kinds, this problem is not that difficult, because we know that every angle or every triangle, the angles add up to be 180. So once we understand that this angle and this angle are the same, then we can just add them up.